All right. So, welcome everyone to your Thursday evening dose of astronomy. Glad to have you here with us. I'm Irene Pease with the Amateur Astronomers Association out of New York City. You can find us at aa.org, follow us on social media. And also, just want to mention the displays, the visuals that we're using. You can find and download those programs and use them yourself. Right now in the background, you see Open Space, which you can find at openspaceproject.com. That's openware, open software. You can download it for free, put it on your computer, and fly around in space just like we'll be doing in a little bit. And also I'll be using Stellarium. We'll switch over and just kind of start off looking at the night sky with Stellarium. You can find that at stellarium.org. So tonight I got my itchy feet. I just, it's not a rash or anything. I just want to get out, go explore some things hopefully, and kind of see where people might be heading next. So in the background already, we kind of have the International Space Station. I usually don't have that on. If we just click over here, usually don't have this little line on, but just to kind of get a feel for where we're going to be headed. Right now there's people on the space station, but I kind of want to just take a look at where people might be heading next for our next adventures beyond planet Earth. So let's go ahead and check out first what's in the sky. So pop over to Stellarium, and we're looking south. I think the tree is back. Is the tree back? In the west? There's that tree. Okay, fine. So the sun is already set. We're getting a little bit closer to the equinox, mid-September, mid to late September. So the sun is setting earlier, so we have our longer night skies, which is great. Hopefully people had a chance to see Jupiter and Saturn. They're still out there this week, so I'm just going to keep reminding you every week, or at least every time I'm doing this. And the really exciting thing that I wanted people to check out this week is a little bit later in the evening. So we're going to look over towards the southeast, east or southeast, and we're going to advance the time until Mars is up. And really, we want tomorrow night, not tomorrow night, 2 nights. So Saturday night, September 5th, the moon is going to be very close to Mars. So that's pretty exciting. It should make for some really nice shots, either just like looking at it with your eye or getting some views of it through binoculars or telescope, depending on if you have a wide field of view in your telescope, and maybe some interesting images. So I'm looking forward to some beautiful pictures from AAA's astrophotography group. We have a lot of really experienced and very talented astrophotographers, so hoping we'll get some cool pictures of that. No pressure, people. And for all I know, it's going to be cloudy, but I think it's actually going to be clear in New York City for the next few nights. So we'll see. So if we zoom in here, we can see just kind of how close they'll be. The moon isn't magnified in this view, and we're getting this kind of estimate field of view if this is about a degree. Remember, the moon is about half a degree across, so the whole sky horizon to horizon is 180 degrees, and the moon is half a degree across. So Mars is going to be less than a degree from the moon. But as I said, this is seen from New York City, so we are in Brooklyn right now. I'm in Brooklyn. This Stellarium is set for Brooklyn, and well, not right now, but 2 nights from now around 11 p.m. But if you're at a different latitude, if we have, I know we've had some people check in from other latitudes when we did the southern skies. We actually had someone watching from the southern hemisphere, which was fabulous. So if you're still watching, if you're listening, this is actually going to be even cooler from the south. So I actually want to check that out. So here from New York, from northern latitudes, it'll be what we call a conjunction, where these 2 celestial objects appear very close to each other in our sky. They're still very far apart in space. The moon is a lot closer to us, and Mars is much, much further away. But they kind of scoot past each other in the sky and look very close. So that's a conjunction. Let's go ahead and take a little trip to the south. So I'm just going to go due south. I think we're going to end up in the ocean, which is okay. You know, ocean works too. And we're going to go down, 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 down. So this is down 0. And I'm trying to remember how far south I went earlier. Didn't actually write it down, but we're going to go down. So if we were like in Chile or Argentina, take a look. I zoomed way in on the sky. So let's zoom out a little bit. And I'm going to adjust my time back to, this is a little after 10 p.m. And we can see Moon and Mars very close to the horizon from this location. So I probably could have gone a little further east actually to land and not just be out in the ocean. But you get the idea. So at these southern latitudes, if we kind of watch Mars, well, actually, it's the moon is moving across our sky faster than Mars is. But what's happening is, oh my goodness, it's like they get so close. Let me just pause time here. Go back a minute. Oh, it's like they get really close and they kiss and then the moon eats it. So, so that's pretty neat. So it's actually going to be an occultation where Mars will pass behind the moon, or we'll say the moon passes in front of Mars and actually obscures our view of it. So that's even more exciting. So if you're in the southern hemisphere and it's clear outside on Saturday night, definitely check this out. Should be pretty great. And so moon will be blocking Mars for about an hour. So if you look back, find the moon again, just fast forwarded an hour. And this is actually really neat just because of the phase of the moon. So I'm rewinding this. I guess depending on your latitude, it could be a little bit shorter, a little bit longer, depending on if it's going like all the way behind the main part of the moon, like across the widest part, or just kind of a little piece of it. So it's going to be a little bit location specific. But if we come back and look at it, I guess at this latitude, so maybe half an hour later, and we see the Mars will actually be kind of poking out from what would be kind of the dark unlit part of the moon. So almost like it's appearing out of nowhere, which I think it's just amazing. Like I would kind of wish I could just go see this, like just take a trip for, just the weekend like you do. But yeah, so we can see Mars just kind of peeking out from the unlit part of the moon. So the part of the moon that's facing us, but because of its gibbous phase right now, Mars will be coming out from like a darker part of it. So that will look really beautiful in telescopes. And so again, really looking forward to maybe some of the images that folks in the southern hemisphere are able to take of this occultation. So conjunction from the north, occultation from the south. But wherever you are, I hope you get a chance to check it out. So if you have clear skies Saturday, definitely go see that. So that's your fun thing in the sky for this week. And we can pop on over then to open space and leave planet Earth, shall we? So back to open space. Like I mentioned, I just kind of want to get away and explore maybe some places that people might be visiting in the coming decade or much further in the future in one case. So the main target, the closest target, I think we already have some plans and possibly a 2024 date in mind, is the moon. So let's go ahead and just kind of zoom out and check out Earth's nearest neighbor in space, our very own natural satellite, Luna. Should have, there she is. So just kind of focus on the moon. Where would we go on the moon though, right? So the Apollo missions were all relatively equatorial, but for future missions, we're considering the poles. So we want to take a look at both of those, just a moment. And just, we'll give them a moment because it'll take a little bit for some of this to load in. My internet isn't doing wonderful things right now. But that'll give me time to talk about open space. So let's go ahead and just look at the south pole of the moon first. So we'll do the south first and see if I can get this as close to 90 degrees south as possible. That's 88. That's probably all that's going to happen. And I'll go ahead and move through time at the incredible rate of maybe a day or two per second. Yeah, a day-ish. So, neat thing about the south pole of the moon, there are spots that are always in shadow, right? So even as you go through the month, as the moon goes through one full rotation, one full period of having sunlight and darkness, sunrise, sunset, one full cycle, takes it about a month. And at the poles, there can be regions that, if they're very deep inside of a crater or similar, they never get direct sunlight. So why wouldn't we want direct sunlight? Well, if you go to the moon, if you want to have like a base on the moon and stay there for any length of time, you're going to need resources, right? You don't want to have to haul everything with you. You have to bring like air and water and food and comic strips and all the things, right? But at these always shadowed regions, we believe there's water ice. So frozen water that is never melted or is never sublimates because it's not exposed to sunlight. So it stays very, very cold and just stays a solid. So there's still the issue of harvesting that, collecting that and turning it into other useful things, turning the water into fuel, but at least you have water to drink. So that's one less thing that you have to bring with you or have regular shipments of. So what we're doing, I'm just going to go ahead and pause. And again, with open space, another fun thing that I can do is I can just go ahead and light up the whole moon, right? So we have open space is basically the platform that we can use to load in and then view data. So this is all real data. So the moon maps that we're looking at tonight are from the Lunar Reconnaissance Orbiter, the LRO, that's been orbiting the moon and taking all these glorious images for quite some time now. And I think I want to rotate this around. I'm trying to, nope, we're good. Orienting myself. And so it's a lot of data, basically. So if you do go to the Open Space Project website and download it, you do want to have a pretty solid graphics card to be able to handle all the data that you'll be loading and streaming. So since it's the pole, we get this kind of odd feature. That's the data set, right? So we're getting these images as the Lunar Reconnaissance Orbiter orbits, and it has like a polar orbit, so it's going around, and then we're kind of like seaming everything together. So there's still some data loading in here, so it's going to clear up a little bit more. Like I said, it's a lot of data, but we have this kind of odd feature of like of looking at the pole. So right at the South Pole, so you can see where these quadrants are kind of meeting, where the data streams all kind of like join together. That hole there, the South Pole, is actually on the rim of this crater. That's Shackleton Crater. So that's been talked about as a potential site for to go to have a base in or around that crater. We'd have perpetual darkness in parts of it, so likely candidate for a lot of water ice and protection from some radiation and things. Other issues with living on the moon, obviously, but that's been one. So Shackleton Crater, named after an English explorer, a polar explorer on Earth. We also have, I thought this was funny, I believe this one here, this larger crater, it has like this huge mountain in the center of it, is Amundsen, also named after a polar explorer. First successful voyage to Earth's South Pole and back, and I do mean successful, meaning they didn't die on the way there or back. So yeah, so this cool crater down here. So some of the other craters that are not quite polar, they might have like little bits of water ice, hidden in some of their darker corners. But Shackleton Crater, way here at the very southern part of the moon, that's one of our targets for a possible base camp. And of course, we're looking at the Artemis missions, right? So the Artemis base camp possibly near the moon's south pole. So all of this has been mapped to 1 meter resolution. So even the dark areas, we have a really good idea of what the terrain is like and where the water is hiding, because you need that. You don't want to just send a bunch of people and be like, well, go see what you find. Like, we want to know in advance what all is there. So that's the south pole of the moon. Fabulous. And there's also some stuff happening at the North Pole. So another potential for finding water is in this kind of interesting feature. So if you look at the moon, the features are, we see light areas and dark areas. So the darker areas, those are the Maria. Those are some kind of relatively newer surfaces formed by lava flows still a long time ago. And we have all these craters, so those are some of the better known features. We have mountain ranges, so actually one of my favorites over here, the Apennines. That's where the Apollo 15 landing was, and I promise we're still going to get there someday in one of these one of these episodes. But another feature that we talk about on the moon, in addition to the mountains and the craters, are rills, which are kind of like these lines that may have been formed. And I feel like we've talked about those on Mars. So like a line, maybe something like this. That's like a really huge one. I don't think that's data. That's actually a rill. So on Mars, we find them, some formed from like collapsed lava tubes and some formed from ancient water flows. So on the moon, not so much, water flows, but some ancient lava tubes. So we're coming in on this crater. This isn't super, super far north. This isn't as far north as Shackleton was as far south. I mean, Shackleton's is as far south as you're going to get on the moon. So this is only about 72 degrees north. This is Valles crater. And again, we'll just let the data kind of load in. You can see there's a couple mountains in here. We'll just let that load. But what we have in here we have some of these rills, sinuous rills that are probably from collapsed lava tubes. And a feature that I learned about this week when I was, reading up on this, they have sometimes these holes in the lava tubes. So like if you've been to Hawaii on Earth and gone through some of those lava tubes, just, tubes like carved out, but there's, big gaping holes where you can go spelunking in as opposed to like walking in from the side. So those, if it kind of collapses in, then you get these features that they call, wait for it, skylights, which I think is just so pretty. So these skylights, like they're letting in this view of the sky from above, but they look different from the crater. So if you see a crater on the moon, like over here, we have a little crater down towards the bottom, and you can see like the side of the crater lit, and obviously this is a much bigger crater, so this is the one that we want to focus on. But even like these tiny craters, so the skylight is going to be a much, much smaller, much darker spot. So in Valles crater here, kind of the northeast side, in this region over here that looks kind of like boring and ho-hum because there's the mountains and these other kind of neat features in the other parts of the crater. Still loading in, like I said, it's a lot of data. But along in this region, we do have some of those rills, and some people have actually found, I think it's a professor at Harvard, I believe, that has identified, actually I could be off on that, but people have identified skylights in the rills in this crater. So it's a huge crater. It's like 70 kilometers across. But they're saying, you have this big flat area, you have these skylights. So the skylights allow easy access to the lava tubes, which are basically kind of underground empty chambers. So, think, spelunking on Earth, you go into a cave and, it's cooler down there. So even if it's really hot in the day, I know I've gone and visited caves in the Southwest, and they're like, bring a jacket. I know it's August in Arizona, but bring a jacket. It's 60 degrees in this cave. So it's going to be cooler. So you could have ice that remains solid water ice, maybe in these lava tubes. And the Skylights offer easy access to that as opposed to having to drill down or something. So this could be like maybe another potential target. I know there's other groups that have talked about visiting the North Pole on the moon as opposed to the South Pole for similar reasons. So some regions at the poles are going to have perpetual darkness, so good places to get water. And then also if you stick your solar panels high enough up, then they will have perpetual sunlight even as the moon rotates. So that's very useful to have that source of energy throughout the month or throughout the lunar day. So some cool places on the moon that we might want to visit or build a base or, whatever. So book your tickets soon, kids, because they'll sell out. And of course, after the moon, it's onward to Mars, the Mars. So, so apparently, there was actually a conference, and I'm not sure when the next one is, but I kind of want to go. There was a conference back in 2015 about, hey, if we're going to Mars, like, where on Mars? Like, where should we go? And so people were looking at actually like different sites and doing like site analysis of like where's the best place on Mars to set up a human base. So let's go check one out. There were a lot of contenders, and I don't know the exact outcome of the conference. If anyone knows, feel free to put that in the chat, share that. But a lot of contenders. So a lot of things to consider. I mean, you want to consider like, can you land there? Do you have resources there? Can you, what can you learn from there? So actually, let me just pull out and find the region that I'm looking for. So here we have kind of the Tharsis region. There's Olympus Mons and 3 other huge volcanoes, and we're just going to kind of skip a little bit back in time to rotate around so that the region that we want to see is lit in here. So here we have, there we go, this big chasm, this big gash across Mars' surface, the Valles Marineris. That's basically the width of the U.S. End to end, so like from New York to L.A. And then below that is this kind of like, I don't know, like I never really paid it any attention before, to be honest. Like this region, doesn't that look exciting? Yeah, hey, let's go visit that. It's so exciting that I'm not even sure that I could find the exact spot. So I left myself a little cheat sheet. There we go. Okay. All right. So in here, this is kind of southern Nectaris. So this Nectaris region that's kind of below the Valles Marineris. So it's not quite equatorial. A lot of the regions that folks were looking at were kind of equatorial, but I think this is the Neat crater. But I'm going to go ahead and bring up another data set. So we have really high resolution maps on Mars, kind of like we have the really high resolution maps on the moon, because we have things orbiting. And I'm not bringing up, I don't have in here the super high resolution, the high rise sets that we have for several regions on Mars. There's lots of high rise data, and it just takes a lot of time to get it all loaded in. And actually, I think I may have missed my target here. Let me take another quick look. Oh yeah, no, that looks like it. Yeah, that's it. Okay. So yeah, this is kind of the crater that I was looking for. So the landing region, so this is a proposed landing zone to set up a base camp, and you ask yourself, why, what's going on? So a lot of craters, great. Okay, so there's craters all over Mars, so HK. But But yeah, so this one's pretty interesting. You have kind of like a layered crater on a crater effect. And so some really neat things happening there. The presenters for this region basically refer to it as a microcosm of Martian geology. So some super pluses of this as a potential human base would be it is open and relatively easy terrain to set up on, to land on, to set up on, and to walk across to access all these really interesting features. So you don't really want to land like on the edge of Valles Marineris and have to go like hiking up and down these massive cliffs every day. Like maybe that's not so practical. There's probably some resources around, but you have craters to explore. You have these kind of features that are formed from ancient water flows. So you have that kind of debris that could contain maybe ancient microbial life to, look in there for ancient life. So just a lot of different types of features in a relatively small area around this site. So relatively safe, super interesting, lots of interesting science topics to be explored there. So that's one of many propose spots to maybe put humans. So we'll see maybe in the next decade or so where we actually end up going. But that's just one, this southern Nectaris below Valles Marineris. So yeah, so if you wanted to go hiking in the canyons, that would be more than a day trip to get up there from down here. That's quite a hike. So that's Mars. So that could be fun to explore. But I wanted to look at one other thing, partly because I haven't done it in a while. I like to do that thing, where I turn on the constellations and just kind of compare how they look in different regions of space. So I'm going to bring up our constellation lines and maybe we make them just a little bit darker so you can see them a little better. And you notice that from Mars, we're seeing the same constellations that we saw from Earth. So if you're familiar with the star patterns in the sky, they look the same from Mars as they do from Earth. They look the same really from everywhere in our solar system. So if humans were to leave the solar system, if we were to visit maybe a nearby star, everybody think of a nearby star. Pick your favorite nearby star. So here we are outside of, depending on how you define the solar system, here we are out beyond all the planets. No change in the stars. And I'm going to bring up this other nifty feature, the Oort sphere, right? So we sometimes define the edge of the solar system as the Heliopause. That's where the Voyagers have reached the Heliopause, kind of where the magnetic influence of the sun's magnetic field is kind of reaching and is interacting with fields from interstellar space. And then out here, the Oort orb, our Oort sphere, this grid, is where we believe the extent of the Oort Cloud is. So those are small asteroid comet-like objects where very, very long period comets might come from. And they're way out there. They're like halfway basically to the next stars. And if we still look around, like I said, we're over a light year away. We still don't really see a whole lot of change in the constellations. But let's just go ahead and take a look. I'm gonna move around. I think we're about, it looks okay. We're starting to see some warping in the constellations. Like I can see a star in here that's starting to look like that constellation is getting bent slightly out of shape. And and I believe we can see Alpha Centauri down here. Oops. Kind of coming into view. So Alpha Centauri is really a full star system, and it does actually have a planet or two or three. If we can turn on the exoplanets, boom. All right. So because we're so close to the parent star, the little circle kind of ebbs and flows a little bit. So all of these circles represent not exoplanets, but they're circles around stars that have at least one or more planets orbiting them. So some of these circles represent 2 or 3 or 5 or 8 or however many planets orbiting a star or multiple stars in that system. So a lot of star systems, like the Alpha Centauri system, I'm just going to go ahead and call it a system, they have multiple stars. So our sun is just a single star, but Alpha Centauri has 2 bright stars orbiting each other, A and B, and then C is a dimmer star. It's like a brown dwarf. And so we have multiple exoplanets in that stellar system. So there's the big circle. So we're like really close to Alpha Centauri. That I think the bright light is AB. So if we just kind of, maybe I'll turn off the exoplanets and just kind of take a look around at the constellations. So if we're looking back towards Earth, right, looking back towards the sun, we don't really see much change in the constellations looking off that way. But if I turn around and we look in the other direction, let's check out the Big Dipper. Big Dipper, yeah, that's fine. Little Dipper has become a little bit more of a hatchet. So Little Dipper, we're seeing a little bit of a different shape there. If we turn around and look at Centaurus, that's going to be, missing at least one star because we're orbiting the star. And we are kind of looking towards the southern sky, which a lot of folks might not be as familiar with. One thing I picked out, where to go, was so this constellation is that's completely flipped. Like those are a little bit off. This one we can tell that's been warped a little bit. I believe Sagittarius looks a little bit different than we're used to seeing it. Cetus looks very different. Cetus is kind of flip turned. Here's Cetus over here. So this is Cetus, and normally it's like kind of a box and then a line and then another little box, but this box is like kind of twisted a little bit. So if we did get to even just our nearest star system, most of the stars in our night sky are going to be, pretty similar to what we're seeing on Earth, but some of them are going to be a little bit different. So let's just head back to Earth. I don't want to leave you way out in the middle of, nowhere-ish, middle of Centaurus, I guess. And we'll end our little trip heading back home. Just a quick announcement for next week. I'm taking the week off. So we have another exciting thing. We're going to try some other kind of live short talks for AAA. And so next week, I think we're going to be kicking it off. So check out our social media channels. We'll have that posted. But come back and learn about gravitational waves. So those should be pretty exciting. Let me just put up our credits real quick. And here we are back home. Home sweet home-ish. Not quite home. We'll just stay out here a little ways. Don't need to get too close. So again, thank you so much for joining us. Again, I'm Irene Pease with the Amateur Astronomers Association. We're in New York City. You can find us on our website, aaa.org, and you can follow us on the social media things at AAADOTORG. And again, if you like the visualizations that you've been seeing, you can find those, download those, play with them yourself, explore the universe. Open Space, which we have in the background now, is available at openspaceproject.com, and Stellarium, which we saw earlier, is available at stellarium.org. So enjoy your week. Check out Mars, all the Mars things that are happening, and be safe out there.